about basanite specifically, which was in my master's thesis, and I wrote a paper about basanite, and they didn't cite it. It's like, oh, it's old at this point. It says I wrote it like 20 years ago.
Okay, we'll get going and we'll jump into that in a bit. All right. Hey, everyone. Welcome to Space Club. My name's Danny Bednar. I'm part-time assistant professor in the Department of Geography and the Environment at Western University. With me, as always, is Dr. Phil Stuke, Professor Emeritus from that same Department of Geography and the Environment at Western University. Say hi, Phil.
Hi.
And with me is Tanya. My favorite Star Trek show is Voyager Harrison, geologist, Martian geologist, overall space person. Say hi, Tanya.
Hello.
And today, when I click through, we are going to Mars. On Space Club, we're going to be talking about the Soviets to Mars. This is, I hope it's not recording that as well. This is art by a Canadian artist, actually from Toronto, Nathan Nunn. He does a lot, or they do a lot of Soviet-themed cat space art, and they have a lot of pop-up shops, I imagine, in Toronto. But I have some of their work around my house, and this is one of my favorites. And thought it was fitting for today. But before we go back in time, regardless of when you're watching this, you may be watching this in the future, but I think even in future semesters, or if people are finding this online and not 2025, this paper that we're going to talk about is probably still relevant. It's probably one of those papers that, I can leave it there. One of those papers that, may get disproven, may not, may be debated forever. But long story short, and we'll talk about this in a little bit more detail. A question, evidence potentially of past life on Mars. So I just want to, that was bothering me. So I'll briefly talk about this because Phil's going to do a lot of talking, so I'll try to give him a break. And then Tanya can correct if anything I possibly get wrong. But this paper came out last week. It got quite a bit of press, although not necessarily a ton. And it's the culmination of over a year's work. So in my emails to Tanya and Phil, I was talking about that. They may have been aware of this work, and certainly Phil would have been aware of this imaging in the blue bright angel environment in Jezero Crater and the sample taken there, which comes into play in this. But long story short, I'll actually read the whole abstract. I actually find it interesting. The press on this is, as usual, much more exciting than the abstract. The abstract's quite subdued, even compared to, I think, the extent to which a lot of very reputable scientific people are talking about this paper. The abstract is extremely subdued. So the Perseverance rover has explored and sampled igneous and sedimentary rocks within Jezero Crater to characterize early Martian geological processes and habitability and search for potential biosignatures, so evidence of life, past or present. Upon entering Neretva Vallis on Jezero Crater's western edge, so this is the large crater that Perseverance rover is in, Perseverance investigated distinctive mudstone and conglomerate outcrops of the Bright Angel Formation. So that's just the proper name that the mission team has given to this formation, Bright Angel. Here we report a detailed geological, petrographic, and geochemical survey of these rocks and show that organic carbon-bearing mudstones in the Bright Angel Formation contain sub-millimeter scale nodules and millimeter scale reaction fronts enriched in ferrous iron phosphate and sulfide minerals, likely vivianite and greigite, respectively. This organic carbon appears to have participated in post-depositional redox reactions. Bit of a deep dive into geochemistry there. We don't necessarily need to get into that to talk about the importance of that in this paper, but that produced the observed iron phosphate and iron sulfide minerals. Geological context and petrography indicate that these reactions occurred at low temperatures, which actually, when you dig into this, is actually part of the mystery, and I think one of the more interesting aspects of this find in this question. Within this context, we review the various pathways by which redox reactions that involve organic matter can produce the observed suite of iron, sulfur, and phosphorus-bearing minerals in laboratory and natural environments on Earth. Ultimately, we conclude that analysis of the cores sampled collected from this unit, which is sitting on Mars right now, using high-sensitivity instrumentation on Earth will enable the measurements required to determine the origin of the minerals, organics, and textures it contains. So this is extremely subdued and extremely academic, and rightfully so. It's an academic paper. Long story short, they came upon essentially this mudstone, and this is at the 5 millimeter scale. You can see the scale bar here. And what they're focusing on is this kind of this feature here, these spots. Again, I'll let you guys correct me if wrong, but the big thing here, and then these reaction fronts that are pointed out, is you have one color, and then you have another color, and then kind of like the baseline mudstone behind it. And what, long story short, I took from this is a chemical reaction or a process has occurred to kind of separate the materials, where you get this inside color and this edge reaction front, this other color. Now, that process could happen naturally, but typically would happen at high temperatures, which they said in the abstract. None of the evidence around this area said this was a hot area. So the other way this can happen is if there's biology present. There are microbes on Earth that would get into a mudstone like this and do stuff that would create this kind of separation and these reaction fronts. Now, this is a classic astrobiology conundrum, is we have a thing we saw that could have happened without life, or it could have happened because life was there. We've seen this many times on Mars as well. Curiosity coming across a methane spike from the ground, the Allen Hills meteorite on Earth, and it having potential fossils in it, but it could also just be geological features that look like microbe fossils. So that's the nuts and bolts of this. Tanya, I know you read this quickly before coming here. One, did I get it vaguely right as you understood it? And I know you're not technically a geochemist, are you?
No, I don't know very much about geochemistry, so a lot of the details in the paper kind of go over my head. But I think what you've summarized is pretty accurate, and I'm surprised. I'm glad that you brought up the sort of concluding paragraph of the paper here, because I was about to go look at it while you were showing the abstract, because I'm surprised at how bold the conclusion is, whereas the abstract doesn't really convey the significance of what the authors are saying this paper is showing us. Maybe that's a good thing, to be overly cautious. You know, the Allen Hills meteorite is sort of like a once bitten, twice shy example of we don't want to say we think we found evidence of life on Mars again and then find out that we were wrong. And, you know, like you said, we've had this kind of thing happen before. And if there's anything Mars has been really good at ever since the days of Viking, is teaching us about ways that things that we think are biological, because our only sample set before was Earth, can also be formed geologically in ways that we just didn't know about, because, you know, Mars is very different in terms of the environmental conditions. So this is very exciting. Since I don't know enough about the geochemistry to get super excited about the specific minerals that they've found, I don't know how hyped to be. But I think because of the previous times that we've seen stuff in this general vein from Mars before, I'm not like, oh my gosh, this is definitely life on Mars. I'm still more in the camp of like, we probably have a lot of geological processes that we have to rule out first.
Yeah, another piece of evidence that could knock over the domino of, oh yeah, no, there's life. But if so, this may be like the first tick. And they mentioned very specifically, it'd be nice to get those samples from this exact area. Phil, maybe that's something you locked onto, but your thoughts on the paper? I know you said you caught it last week.
And I think you're right to sort of raise the idea of how nice it would be to have those samples back on Earth, because, to be honest, nobody is ever going to be able to prove anything from what we have at the moment, where the samples are still on Mars and we're just analyzing analyzing them in several different ways. I mean, Perseverance is wonderfully capable as an analytical machine, but we're not going to get close enough to the details of this without having the thing on Earth. And so it really would be good to get those samples back. And that's why Perseverance has been collecting samples, but the whole process of getting them back is completely in disarray at the moment, and we don't know how it's going to happen, or even if, I guess, it's going to happen. So this paper is a really strong plug for getting those samples back as soon as possible.
Yeah, I mean, it's essentially saying, like, we had the nebulous idea that these samples are important, but this is actually saying, like, we know there's something in one of them that, like, we really want to get a look at, and that's a little bit of a step forward. And there's no, to my knowledge, timeline on these samples that they're going to go bad or anything, but no. Obviously ideal, we want to get them home. Yeah, so like I put the summary there too for my students and anyone watching, and you know, I think all of us, maybe, I think certainly Tanya and I, with some of our friends and family, will get, you know, forwarded an Instagram short or a Facebook post about space that is often very bold and very striking in its claim. And I often bore my family members to death by saying, like, things like what is in the end of this paper, a feature that is consistent with biological processes and that, when encountered, challenges the research to attribute it either to inanimate or to biological processes, compelling them to gather more data before reaching a conclusion as to the presence or absence of life. Which is an extremely scientific thing to say, right? Like, this puts the team who gathered this, and now all Martian geologists and planetary biologists and stuff like that, in a position where, okay, well, we need to decide. Well, we don't need to decide. We need more evidence to rule out how this was done. And there's lots of examples of this, as we talked about. But that also reads to me like a sentence, and I think both of you would be more plugged in on this. That reads like a year's worth of arguing by email, because this paper, I think in the press release and in a few of the mainstream news articles about it, there was an emphasis on, like, after a year of analyzing the data and going back and forth, researchers finally published their work in Nature. And you guys also know all about, you know, this has been known in the small space sector, I'm sure, for a long time, but the publication usually takes a while and all that. Tanya, you've been involved in stuff like this where emails go back and forth on how strong are we going to say this or that, and can you just imagine what this one was like?
Oh yeah, I'm sure, again, because of what happened with the Allen Hills meteorite paper, that people were very, very cautious about how they wanted to word anything in here. And I mean, there's like a dozen authors on this paper, so I imagine the process.
5 dozen.
Yeah, I imagine the process was very complicated. And I think it highlights how important the length of these missions really is, because Perseverance has been on Mars for like almost 5 years now. So it took about 4 years to find this location, get this sample, and then another year to analyze it and get this paper out the door. So it took a long time to find this, you know, potential smoking gun evidence for what could maybe be evidence of life on Mars. And if this mission, you know, hadn't driven this direction or hadn't lasted this long, we may have never found this. So that's why we keep these missions going for as long as we do, because you never know what you're going to come across.
Yeah, that's right. I'd like to just say something about the sort of the context of this. Perseverance went to this place, Jezero Crater, because it looked as if the crater had held a lake, and a river flowing across the surface outside the crater had broken through the rim into the lake. Maybe that's what filled the lake in the first place. But as it flowed, it brought sediment in and built out a delta into that lake. And that's why the site was chosen. It strongly suggested that not only there'd been water there, but it had been there for quite a long time as the river slowly built out this delta into the lake. And this particular site at Bright Angel is inside the valley that was doing all this work. It's just inside the crater rim. So this channel has been the channel winds across the surface outside the crater and cuts through the crater rim and leads down onto this delta. And so part of the channel is on top of the delta. That's where they are here. And they're looking at bright sediments, a little patch of bright sediments on the floor of the valley. One thing that's not really very clear to me, and I'm not sure, I don't remember whether they get into this in the paper or not, but it's not quite clear to me whether those sediments on the valley floor would actually be sediments deposited in the river itself while it was still flowing, perhaps as it was slowing down, just before it dried up, or whether in fact those are much older sediments that have been revealed by erosion as the channel is cutting through it. So I'm not quite sure of the context of those rocks right now.
Yeah, it's something we can update in our to come future post video or episode of Space in 2026. Maybe we can provide an update on where this has been. But yeah, the context of this is key. And like I mentioned, there's some work in the paper, but the extent is not the focus of the geological context of all this and identifying, like you said, was this placed here or is it older? Okay, well, let's move on or go back in time, I suppose, to something I wanted to talk about. And that is the Soviet missions to Mars. I think unheralded, although in this day and age, with everything is heralded, there's YouTube videos and posts and videos and blogs about everything. But I wanted to talk about this with Phil and Tanya, and specifically Phil, of course, because he's done so much work in this area. As I was reading my International Atlas of Mars Exploration, the first 5 decades, the first decade specifically is filled with Soviet spacecraft. So, Phil, before you take it away, can you read the citation for this image?
Right, Mars 3 lander and rover, and then there's supposed to be 2 brackets around this, but I seem to have missed out the end one. It says Muzej Kosmonavtiki Rossiya. Museum of Cosmonautics in Russia.
I didn't know you could read Cyrillic. I actually was just teasing.
Oh yes. Oh, you were.
Yeah.
You misjudged me, Daniel.
I did misjudge you. You've looked at so many Soviet maps that you just learned Cyrillic by osmosis.
Well, going to Russia a couple of times helps as well.
Oh, okay. All right. Well, tell us what time Russia went to Mars.
Well, go back to the previous slide.
Okay.
Because I want to look at that picture, which is a picture of the Mars 3 lander and rover, as it says. The rover is the funny little black rectangle right up on the top of it.
Yeah.
When the thing landed, the odd triangular petals, you can see 3 of them, and there's a 4th one around the back. They were folded up over the top of this to enclose it. And when the thing landed, it opened up its petals. And probably, although I don't think it's quite clear, probably that black thing, the little rover, was flipped down onto the surface on a sort of folding arm. It would bring it down to the surface. And then it's supposed to be able to drive away. We don't really know whether that happened or not, but when that moved, it would have exposed 2 cameras. And the cameras are right up on top of it, 2 little scanning cameras. Now, the reason I wanted to come back and talk about this is because at the end of this presentation, we're going to see a picture. It's a drawing this time, not a photo, but a picture that looks very, very similar to that.
Okay.
And I'll say something about that when we get to it. So now let's move on.
Now, I'm going to use my expert analysis and point out that this is a model on Earth. This is not on Mars.
I'm glad you mentioned that. Well, okay, so the Soviet Union, just like the United States, was pushing out into space with its probes. It did things at the moon first, but they wanted to go on to Mars as well. And they started very early with 2 launches in 1960. Imagine how early that is in the space program. 1960. The launches themselves failed. And then they launched 2 more in 1962, and those spacecraft got into space but failed pretty quickly. This was a time when lots of things failed. We were still learning how to do this. It was very difficult. So it's perhaps not too surprising that some of those things would not have worked at the time. Then in 1964, the spacecraft in that picture, Zond 2, was launched to fly past Mars, and it again failed on the way to Mars. And as far as we can tell, it was mainly an engineering test, testing propulsion, navigation, all the kind of housekeeping chores that a spacecraft has to do to keep itself operating properly. And it wouldn't really have done much science, but it was trying to basically get people past these obstacles of flying something in space that was making it so difficult to do. So early missions in the early 60s didn't accomplish very much. So now let's move on to the next one.
I'm quickly searching when in 1960 this was, because to me that's wild. So like Sputnik is late 57.
Yeah.
And you're jumping straight to hitting Mars. Like we just put something in orbit around the Earth as humans, and the Soviets were like, Mars. Like that's a ridiculous jump in confidence.
It would have been difficult, but actually, if we come back to 1964, when this spacecraft was launched, that's also the same year that the US launched Mariner 4. Well, they launched Mariner 3 and Mariner 4, but Mariner 3 failed. But Mariner 4 successfully got to Mars and photographed it. So it was possible to do those things at that time, but very difficult.
Yeah. Yeah, and I mean, those 4 years, 60 to 64, there's just a plethora of launch. There's so much going on so quickly. Yeah, it is also, the difference between even 1960 and 57 is fair enough. The difference between 64 and 57, by that time, there had been quite a bit of launches. But yeah, it is remarkable. Even 64, that's less than a decade after the first thing intentionally put into orbit, or put into orbit at all. Always wild to look back at the timelines for the space race, because it is just completely unprecedented.
Okay, so now we come up to 1971. So there's quite a gap there. So 6-7 years, enough time to develop things further. So now they can be successful. There was a Mars 1. That was one of the 1962 missions, and it failed. But Mars 2 and Mars 3 actually got to Mars and were able to do something at Mars. So that's a step forward. The image shows several pictures from Mars 3. Now, Mars 2 and Mars 3 were landers and orbiters. So there was a Mars 2 orbiter and lander and a Mars 3 orbiter and lander. And Mars 2, apparently its orbiter made it into orbit, but as far as we can tell, it didn't really do anything. So it may have failed at that point. And the Mars 2 lander entered the atmosphere and crashed. So it didn't accomplish very much. But Mars 3 did much better. It got into orbit, it made orbital observations, and it dropped its lander to the surface. These pictures are all from Mars 3, and they show some distant shots of Mars. There's one in the middle right that shows a layer of haze above the horizon, and then 2 close-ups. Now, I'm not cherry-picking from thousands of pictures. These are pretty much the only pictures that we've got from that mission, and especially the 2 high-resolution images. They don't look very good because there was a giant dust storm raging on the planet at the time, and the US suffered the same problem. They had an orbiter, Mariner 9, that went into orbit at just after these 2 arrived. No, actually, I'm wrong. It got there just before they arrived, sorry. But it was also stymied by this dust storm. But it could last long enough. It lasted for many months, and it lasted long enough for the dust storm to clear so they could image the surface. Mars 2 and 3 didn't last long. Mars 3 it only got a few pictures, and then there weren't any more. So it didn't actually survive long enough to give us anything better than these rather fuzzy-looking pictures.
What is the feature in F?
It appears to be a crater rim.
Oh, okay.
And
Like
I guess
nothing
if the
specific.
crater rim is raised up a bit above the surface, there's a little bit less dust hiding it. And there's more sort of dust billowing around the outside of it and inside the crater. It's a funny looking picture, but that's probably what it would have to be.
And then, E, Tanya, you could do some science with this. You could see some gullies and stuff, assuming the scale is what I think it is. You got some features there. You can do some science.
There's some stuff happening there.
There is. That is on the northern rim of the Argyre impact basin.
Okay.
And we're going to come back and look at that site later. But that's where it is. So you've got the mountainous rim on the top of the picture and smooth plains at the bottom. Okay, so Mars 2 and 3. Mars 2 got to Mars. It entered the atmosphere. And when you get to Mars and you want to drop something to the surface, you don't just head for the center of the disk and go straight down through the atmosphere, because the atmosphere is very thin. You have to head for the edge of the disk and go through quite a long distance through that thin atmosphere so that you can slow down enough to release a parachute and go on down to the surface. So you come in at a very shallow angle, and this map of the edge of Hellas Planitia, the edge of a giant impact basin, shows roughly where the spacecraft entered the atmosphere and where it hit the surface, and they're several hundred kilometers apart because they come in at such a shallow angle. Now, the question is, why did they come to this place? These spacecraft were launched and targeted before we had any useful pictures from Mariner 9, anything that could help tell us about the planet. So they had to be aimed based on information from before Mariner 9. And the reason is that in 1969, NASA had two flyby spacecraft called Mariner 6 and Mariner 7. And Mariner 7 took pictures of this area, and they showed craters and so on outside the impact basin, but the floor of the basin just looked absolutely, totally featureless and smooth. So it looked like it would be a safe place to land. What wasn't obvious at the time was that that apparently a smooth plane was actually, the basin was full of clouds. So there was nothing to see. You couldn't see the surface. So they didn't really know what they were getting into. But that's why they chose that spot. It was one of the few places in the latitude range they could go that looked very smooth. But they crashed.
Yes, young space entrepreneurs do not mistake clouds for smooth in identifying a landing region.
That's right.
What is Hellas chaos? Is it really rough?
At this scale, we can't see how chaotic that landscape is. But if you zoom in on it, it's a very rough area full of little jagged hills and ridges. So it's a very, very rough surface. And those features get called chaos on Mars.
But you were mentioning too the question of why would we land here, or why would they try to land here? The first thing that came to mind was, isn't this very low altitude as well?
That is a very good point that you raised there, Danny.
Let me finish, because my students aren't as smart as us, right? Well, a lot of them are smarter than me.
Okay,
but the reason you would go to a low altitude area is it gives you more atmosphere before you experience what our friend Dr. Matt Cross calls lithospheric braking, which is splatter hitting the rock. So if you go to a low-lying area of a planet, you get a little bit more atmosphere to help you brake, I believe. Not that I've ever designed.
No, that's true. But the thing is that we really didn't know at this time very much about the topography of Mars. It really took the Mariner 9 mission again to reveal topography. And it didn't have an altimeter like we would expect a modern mapping mission to do. It was measuring thousands of occultations of the radio signal going through the atmosphere at the edge of the planet to see how dense the atmosphere is, doing that all over the planet. Anyway, the point is, they didn't really know much about Hellas, but there was some indication from the Mariner 6 and 7 missions that it was a depression. We just didn't really know very much. Anyway, it looked promising. It has a smooth surface. It's probably somewhat lower in elevation, so let's go there. So that's what happened, but they still crashed. Now here's Mars 3. It landed in a cratered area. Actually, it's higher elevation and quite rough, and tracking and everything that they had with the mission to suggest where it was puts it at this location on the edge of a crater called Ptolemaeus. But we think that the target was actually the smooth area that is a little bit to the right of and just above that circle. So just outside the crater, there's a very smooth area. And that showed up in images taken by Mariner 4 in 1965. At the time that these missions were targeted, the only useful pictures we had were from Mariner 4, Mariner 6, and Mariner 7. And only in that smooth area there and in Hellas were there smooth surfaces to land on at the latitude they could go to. So we think that was the target, and they missed it by a bit and ended up inside that crater Ptolemaeus. And actually, it looks as if we actually were successful in imaging the site with MRO. People kept pestering the HiRISE imaging team to go and look at this feature or that feature because it might be Mars 3 and other things of interest. And eventually, they got a picture that shows bits and pieces that look like the hardware from that mission. So people generally think that it is a correct identification.
This is why we need to use orbiters for space archaeology as much as possible.
Right.
As many people may know, or I hope many students know, HiRISE operations, I don't know if they still are, but were once upon a time periodically run out of Western University. And if you were a grad student who was asked to volunteer to support, you could also help within that window choose some imaging sites that were at least within a certain area. And I remember being asked and pitched that. And I remember I had to tell the PI, I was like, dude, I know literally nothing about remote sensing, and like at the level you are requiring of me. I think he saw me all the time at like Phil's talks and other talks, and knew I was vaguely interested in remote sensing of other planets, but I think misinterpreted my expertise. And I was like, oh, it'd be no problem. You could help the HiRISE team. Or like, I would have been absolutely terrified the first day I walked in to be like, yeah, look at this downlink of data. What do we do with it? But if I would have been able to choose anything, it would have been archaeology driven. If I could choose an imaging site on any planet, on Mars specifically. Tanya, have you ever had an opportunity to influence targeting in an orbiter?
For HiRISE specifically?
Or any?
Yeah, I mean, I was targeting specialist for the context camera on Mars Reconnaissance Orbiter. And then if we basically CTX context camera would take context images for HiRISE. So since our footprint was much larger, like 30 kilometers by 100 plus kilometers, kind of depends on the settings. HiRISE is more like a few kilometers across and a few kilometers long, but much higher resolution. So if we spotted something interesting in a CTX image, we on the CTX team could then ping the HiRISE folks and be like, hey, we think there's a new impact crater here, which is how we discovered the ice excavating impact craters back in 2008, 2009 or so. We spotted these new craters in CTX images that had some bright spots in the middle, and we're like, this is kind of weird. Hey, HiRISE, could you come and shoot this? And they took these higher resolution images, and we could see this ice that had just splattered all over the surface from these impacts. And lots of other cool stuff too, like new gully flows and new dust devil tracks, slope streaks, things like that. So it was kind of a cool synergy to be able to see things in a low resolution image and then tip the other team to be like, hey, please go take a picture of this.
And you never targeted the exact gullies you were studying for your thesis? You were never like, oh, by the way, we definitely need this.
Well, I did them before I was working on them for my thesis.
Now that makes sense, actually.
Yeah.
All right.
All right, here's that cute little rover. It wasn't operated yet. We don't know whether it was deployed onto the surface or not. But it
this is on Earth. This is Earth. This is and it's tethered. I think it's pneumatic, isn't it? It's like
it was tethered. It wasn't pneumatic, but it was tethered, so it wouldn't have gone very far. But it had a camera. The funny little thing on top of it is a camera, and there were two cameras like that on top of the lander. Maybe this is a good opportunity to point out that actually one of those cameras operated for about 20 seconds and did transmit some data, but the Soviets concluded that they were not seeing any real features on the surface of Mars. And actually what we think is that each camera, only one of the two cameras worked, but basically that camera would start out looking at the other camera and then sweep out a 360-degree panorama. And we only got the bit that was looking at the other camera, probably. So it did just have some fuzzy shadows and things on it. That's all. So the picture was essentially useless, and it wasn't a picture of the surface of Mars.
Cool concept, though.
Yeah.
The Phobos planned. Wasn't there a similar design for a Phobos like hopper?
Yes, there was, and we'll come to that.
Oh, okay.
So let's.
I also just looked up the definition of rove because for some reason in my brain, rove implies rolling, but it doesn't. It just means moving.
Yeah.
It just means wandering. Although travel consistently without a fixed destination, rovers don't actually, most of them have pretty fixed destinations.
Well, I don't think that it's really appropriate to use a sort of 19th century definition of rove to say what a planetary rover is.
The dictionary on the internet, Phil, says a journey, especially one with no specific destination, that is to rove. Oxford, travel consistently without a fixed destination. I don't know. I think we should rename all rovers, unless they have genuinely no destination. They're just wandering. Which I guess extended missions are kind of like that.
Ah, there we go. Okay, we're good. We're good.
Okay, I've got Phil back.
I want you to find like an industrial design historian or something to go into the aesthetic differences between Soviet era space hardware and like American design space hardware, because they're so dramatically different from one another. Like you see something and you just look, you say that is very Soviet. I would love to hear somebody like dig into kind of the differences in that specifically.
Yeah, that's a good point. Now, coming much further towards the present day, back in the mid-2000s, was the Google Lunar X Prize. And one of the teams for that, a Russian team, proposed a rover called Selenikod, which would have also traveled on skis like that, that sort of ski-like motion. They hung on to that design. Anyway, let's move on here to 1973. The Russians knew that that NASA was planning its Viking mission, which was supposed to launch in 73, but then got delayed to 75. But they were desperately trying to get there and land on Mars first. So in 1973, they sent a whole fleet of spacecraft. Mars 4 and 5 were orbiters. Mars 6 and 7 were landers. And the only one of the whole set that was in any way reasonably successful was Mars 5. Sorry, Mars 5. So let's look at them in turn. Mars 4 flew past the planet. It failed to go into orbit, so it just flew past. But it used its cameras, to different imaging systems, to take a bunch of pictures, which I've laid on a map here just so we can see where they are. We got some pictures from it, but it didn't go into orbit.
Okay, before you, for the 15 years I've known you, Phil, you've consistently erased Mars 3 as the first landing. You just said they were rushing to get there first. No pun intended.
Yeah. But what I meant was, what I meant was that they would like to have a successful landing that was fully operational and sent back beautiful pictures and did stuff.
Well, it was tough times.
Yes.
Okay.
All right. So anyway, now Mars 5 did go into orbit, and so it could sweep over the landing site multiple times, and it took lots more pictures. So this is just showing some of the coverage from different cameras. I just wanted to illustrate the areas that were covered. Not all of those pictures were great, and I should point out that although there was a scanning camera that took a long image swath across the area, there was also a framing camera that took pictures, and that black outline is built up out of individual frames, and they were shot on film, which was developed on the spacecraft and scanned with a microdensitometer and transmitted back to Earth, just the same way that the Luna 3 first images of the far side were taken. So this was still quite early in the period of digital imaging.
So me and the aforementioned Dr. Matt Cross were just talking about this because we were talking about how me more so. I was talking about how I just don't understand optics. It's all magic to me. But we were then talking about like how information is turned into bits and sent back. And then I was like, oh, remember that time when Phil was telling us about, I'm pretty sure it was a Soviet Luna that like chemically developed the film in orbit and then like scanned those images. And I was like, that makes more sense to me, even though it's kind of ridiculous. It was all part of a conversation about how I think optics are magic and I don't understand them. But now I'm also learning that was done at Mars, which I either knew and forgot or never knew.
Right.
And so the development, was it like chemical like?
Right. Well, when people used to do that on Earth, they would have big tubs of chemicals, a developer and a fixer, and you can't have big tubs of liquid floating around in zero gravity. So basically, the chemicals were soaked into a porous surface on a roller, and the film would run through and pick up those chemicals from the roller and get processed and then fixed.
I think
so. It's done like that.
Wow.
Okay. And fancy photographers, maybe even Tanya, if she's still dabbling, do still develop the old-fashioned way, as far as I understand.
I've got the tanks sitting in storage somewhere, but like the fact that it requires so much effort to do it as a person here on Earth, unless you have gigantic machines, like it blows my mind that they could miniaturize that process into something that ran on a spacecraft in the 70s. That's crazy.
Yeah, I know. Well, the Luna 3 one was in 1959.
What? I want to know more, like, what kind of film were they using? Like, I want to see an exploded cross-section of this whole setup. Like, I want to know how it works.
You'd be able to find it if you looked at that.
Yeah, maybe that specifically can be a space club one day. In orbit processing, the earliest version. Yeah.
All right. Okay, so now, what about the two landers? Mars 6 and 7 were supposed to be landers. Mars 6 entered the atmosphere, but it crashed. So it didn't land successfully. But we know where it was going because Russian scientists asked their counterparts at the US Geological Survey to make a map for them using Mariner 9 images of their landing area. And this is so nice. The reproduction of the map. They asked for 2 sites, so we know where the 2 landing sites were going to be. And basically, the landing target was right in the middle of that map. They enter the atmosphere off to the west, and then they land in the center. 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 And then they land in They come in towards the east, but they overflew the target point and crashed on the other side of it. We haven't found that little blop on Mars where it crashed. We haven't found that yet. But of course, it didn't accomplish much except measuring some atmospheric parameters on its way down. Okay, so now let's go on to the next one. Now this is I think I always found this really interesting. I can't say that everybody will. This is Mars 7. Mars 7 missed Mars. So it didn't crash on the planet or land, it just missed the planet. But we know where it was supposed to land because they had the Russians asked the US Geological Survey to make a map of it. And the map is in the white outline there. And right at the center is presumably the target. And it just happens to be also the center of that Mars 3 image. Now, the Mars 3 image that we looked at, and Danny was commenting on little valleys and things there. It's not detailed enough to tell you anything useful about the surface. But the very fact that it was taken meant that they wanted to go there. So they targeted that. And it was a nice smooth spot on the bottom of this giant impact basin. It would have been a good place to land. But they missed.
Interesting. Why were the Soviets so interested in Argyll Planitia?
Well, I think it was just because they had the pre-existing image of it. So they knew it was smooth.
This is the one place. Yeah, that's fair.
Okay, let's move on. Okay,
well,
so
we're on to the moons.
So basically, the Russians did not succeed with any of those earlier missions. And they left Mars alone for a while and went on to look at Venus and things like that. They had much more success at Venus. But in 1988, they decided to fly, well, they decided earlier, but in 1988, they flew 2 spacecraft to Mars to look at one of its moons called Phobos. Phobos 1 failed on the way to Mars. Phobos 2 got there and did operate and look at Phobos a few times. And here's that funny little lumpy potato-like moon. In some of the pictures at the top. And underneath, I've taken those pictures and projected them onto a map of Phobos to illustrate the full imaging coverage from that mission. What did I was going to say something about that. What was it?
Was it the time, I'm pretty sure, you had these like in not paper mache, but if you remembered, I don't want to.
Yes, it wasn't that. No, what I wanted to say was they got to Mars sort of late in '88 or early '89. That was my first year at Western. I was a newbie professor at Western, and in those days, if you wanted to get information about the Russian space things, it wasn't very easy. I used to go to the Weldon Library, down to the newspaper stacks in the days when university libraries took dozens of newspapers, and they were just out there to read. And they had the Russian papers, Pravda and Izvestia.
Cool.
And I would go and look at them and look through them, flip through them, looking for pictures like this. That was how we did things in those days.
Did you read Russian at that time?
Only a few words.
Oh, okay.
But that's how we did it. You'd find something, and I remember seeing a picture in Izvestia from the Luna 20 mission that I've never seen published anywhere else. It was quite a cool thing to be able to do. Okay, so anyway, what Phobos 2 was supposed to do was orbit around Mars and pass close to Phobos several times, making observations, getting a bit closer each time, observing where it was going to land, and then drop a lander onto the surface. Actually, 2 landers. One of them was going to be a static lander. It would sit there and analyze the surface and everything. And the other one was a little hopping spacecraft that would drop onto the surface and then hop around, presumably taking pictures at different locations as it moved around, maybe doing some surface analysis. But that was not to happen, actually. Phobos 2 failed while it was in this sort of orbital phase. So actually it's orbiting Mars and it was passing quite close to Phobos. There would be a pretty good chance that it could have smashed into Phobos in the many years since then. It was designed to come quite close to it anyway, but we don't know what happened. We don't know whether that actually did happen or not.
Okay, so the story I was thinking of is in your office at Western. You had like paper versions, I'm pretty sure.
Oh yeah, I had made paper maps. I made paper maps of Phobos and Deimos.
But they were three-dimensional, like they were like globes.
I made them as flat sheets, but they were designed in such a way that you could fit them together and they would curve around and make that globe.
Yeah, I picked one up once. Yeah, I picked one up and you yelled, "Put that down!" Because
and you made a crater on it, Danny. You made a new crater on it.
The other thing, I was talking with someone recently about this. Might have been Matt Cross again. About like the idea of people used to get newspapers from very far away, like the day of, and like how did like Pravda might have been a day behind, or was it the day of?
No, it was about 2 weeks behind.
Oh, 2 weeks, okay. No. But like you used to get like the New York Times in Winnipeg where I grew up, like the day of at like 6 a.m. Like how did this get here? And I think to this day you could probably get some of the bigger newspapers print versions day of, and I don't understand how that works.
Yeah, well, I guess the first printing would be pretty early after midnight, and they can throw it on a plane, and it can get quite far afield from that. Yeah. All right, and this just shows a map of a small area of Phobos showing where the 2 landers were supposed to touch down. The background image is a photomosaic map I made of the whole surface of Phobos, and it was from that I made those images that went into the fold-up version.
Isn't that? Oh no, that's not the end.
Oh yeah, but Phobos 2 also studied Mars itself. It's orbiting around Mars, and it used various instruments, an infrared scanning instrument, for instance, that made these long swaths across the planet. The moon's orbit in the equatorial plane, so all the observations of Mars are pretty close to the equatorial plane. And this just shows where some of those measurements were made. And the infrared data was actually quite useful and was used by people, not just Russians, but in the West as well, to study things like thermal inertia of the surface and grain size and stuff like that. So quite nice data sets. Okay, and now this. So this is my last slide here, and that's why I wanted to pay particular attention to that first image of the Mars 3 lander. In 1996, there was going to be a new mission, and this was designed. It was a big orbiter, and it was going to go to Mars and drop 2 small landers. This is just a drawing of one of them, and 2 penetrator probes onto the surface. But the small lander looks very, very similar to that that lander from 1973. So they're still using the same basic concept of a design. Obviously, the electronics and everything would be improved, but the same basic concept of a design was still being used. But unfortunately, this spacecraft launched into a parking orbit around the Earth and then got stuck and eventually fell back into the Pacific Ocean. So it didn't get to Mars.
Do you know the details of this MOX? I'm just thinking, is it anything at all like MOXIE on this? Identifies the MOX.
No, I don't think it's anything to do with that, but I don't know what that means. No.
It's international too. You got Finland and France. It's just post-Soviet.
Yeah,
so.
yeah, that's right. There were some components from other places. Germany down in the bottom right.
Right
The
around
alpha
the
proton X-ray spectrometer from Germany is a design that they've used all over the place, including on NASA missions. It's a, you know, that was a German instrument on this, but the Germans built more of those, and then one of the German scientists involved in that moved to Guelph, so he's half Gellert.
Right.
So yeah, they've been using that for quite a long time.
Yeah, APXS, right? It's the instrument. Yeah,
that's right.
To Tanya's earlier point, like when it folds back up, a lot more circles and domes with Soviet spacecraft. Like Lunokhod has that like roundish, and then almost like a circle on top, and then almost like a reverse turtle shell on the bottom.
Yeah.
This too, yeah. Interesting. All right, Tanya, any last thoughts on our Soviet friends' accomplishments in exploring the moon? I mean, Mars.
It's too bad that they didn't have a ton of luck early on, even though they kept trying. But good on them for not giving up after the first couple missions.
I feel like they didn't have a ton of luck, period. What was the most successful mission of everything we just looked at? Mars 5?
Well,
maybe the Phobos
Mars
ones?
5 took some images and made other measurements. So that's pretty good. Phobos 2 got some good data sets for Mars. But they haven't had a lot of luck. They did much better with Venus.
And the moon, obviously, of course.
And with the moon.
With the exception of humans. But I did want to ask, maybe one day we'll visit, and I'm really, really interested to the extent we get information on the Zond everything, the Zond program as a whole, because that name was used for interplanetary spacecraft, but then it was also used for their planned, hypothetical, somewhat developed human spaceflight program to the moon.
Yes, that's right.
And the mission architecture for Zond is something I'd be interested in one day, understanding, comparing it to Apollo and all that. But I just don't know how advanced and how open or how available and surviving any of that stuff is.
Well, the human version of Zond that was going to be like the command service module for Apollo and would take people to the moon, that actually morphed into the Soyuz spacecraft that has been used ever since to fly people up and down to space stations.
All right. Well, thank you so much, guys. I hope you watching, whether you're my students or just interested space fans, learned from Phil, as Tanya and I always do, and we will see you hopefully in about another month. So if you're interested, take a look at all the other Space Club XV videos on YouTube. Some of them are on Tanya's channel. Most of them now are on my channel. And yes, we will be back in the future with more space information. Thanks, everyone.
Okay, thank you. Bye-bye.